So welcome to this today's lecture on heat treatment. So heat treatment process is basically to alter the properties of metal, especially steel. So in terms of steps, heat treatment is process of heating the metal, holding it at temperature for a particular period of time, then cooling it back. During the process, the metal part will undergo changes in mechanical properties. This is because the high temperature alters the microstructure of the metal, and microstructure plays an important role in mechanical properties of material. The final outcome depends on many different factors that include time of heating, time of keeping metal at certain temperature, rate of cooling, surrounding conditions, etc. The parameters depend on heat treatment method, type of metal, and part size. There are five basic heat treatment processes: hardening, case hardening, annealing, normalizing, and tempering. Although each of these processes bring about different results in metal, all of them involve three basic steps: heating, soaking, and cooling. Heating is the first step in heat treatment process. Here you can see that iron carbide diagram. So usually the heat treatment is carried out around this line, that is recrystallization temperature. So or this line. So this line is A1 line. So this either this above this line, this one or this one or this one mostly. Annealing is the heat treatment method where the metals such as aluminum, copper, steel, silver, or brass is heated to a specific temperature, held at that temperature for some time to allow transformation to occur. Then it is cooled. This process increases the metal ductility and decreases hardness to make the metal more workable. Copper, silver, and brass can be cooled quickly or slowly, whereas ferrous metals like steel must be cooled gradually to allow annealing to occur. Annealing may be used before metal is machined to improve stability, making harder materials less likely to crack or fracture. So in annealing, as far as annealing is concerned, heated beyond upper critical temperature, then cooled at slow rate. Annealing is carried out to soften the metal. So I will show this upper critical temperature above this line. So above some 20 to 30 degree above this line, heated, and for steel it is uh, held that temperature for more time so that the transformation taking place. The stress relieving is especially common for boiler pots, air bottles, and accumulators. This method takes the metal to temperatures just below its lower critical temp order. Cooling process is slow and therefore uniform, and this is done to relieve stresses that have built up in pots due to earlier processes such as forming, machining, rolling, or straightening. So usually when you refer iron carbide diagram, stress relieving is done below this lower critical temperature, that is recrystallization temperature, below this. Normalizing is an annealing process for steel where it is heated 150 to 200 degree Fahrenheit, around 50 degrees C higher than in annealing, and held at critical temperature long enough for the transformation to occur. Steel treated in this way must be air cooled. So usually in other cooling process, especially annealing, it is furnace cooled or cooled slowly. Here the cooling rate is little bit faster. The heat treating in normalization occurs smaller austenitic grains, while air cooling produces more refined ferritic grains. This process improves machinability, ductility, and as well as strength of the steel. This temperature is higher than the one used for hardening or annealing. After holding it at this temperature for a designated period of time, it is cooled in air. Normalizing creates uniform grain size and composition throughout the part. Normalized steels are harder, stronger than annealed steel. Tempering is a method of heat treating used to increase the resilience of iron-based alloys like steel. Iron-based metals are very hot, but they are often too brittle to be useful for most purposes. Tempering can be used to change the hardness, ductility, strength of the metal, which usually makes it easier to machine. The metal will be heated to a temperature below critical point as lower temperature reduce brittleness while maintaining hardness. For increased plasticity with less hardness and strength, higher temperatures are required. So this is usually done when the hardness is very high, that is brittleness is high. We have to usually tempering is followed by hardening. Temperatures are usually much lower than hardening temperatures. Higher the temperature used after the final workpiece becomes. The rate of cooling does not affect the metal structure during tempering and usually metal cools in still air. Hardening. In heat treating to harden the metal is heated to a temperature where the elements in the metal become solution. Before doing this, defects in crystal lattice structure of metal are primary source of give or plasticity. Heat treating addresses those deficiencies by bringing the metal into reliable solution with fine particles to strengthen the metal. Once the metal is thoroughly heated to a right temperature to produce solid solution, it is quickly quenched to trap the particles in solution. The main difference here is the cooling is fast. In participation hardening, impurity particles are added to the metal alloy to increase their strength further. The most common heat treatment process of or hardening is used to increase the hardness of the metal. In some cases, only the surface may be hardened. Here you can see the hardening temperature for hypoeutectoid steel and hypereutectoid steel. That is left side of this line, 0.8 percentage of carbon and right side of 0.8 percentage of carbon. So cooling is very cool, very fast cooling in hardening. Case hardening only. So there are few applications like a gear where you have a harder surfaces but soft core. So in those areas we try to do this case hardening process to improve the life of the particular component. The harder outer layer protects it from material wear. When mounting a bearing to the shaft, it may otherwise damage the surface and dislocate some particles that then accelerate the wearing process. The hardened surface provides protection from that, and core still has necessary properties to handle fatigue stresses. So this is how this solution treatment is done. So heat it to a particular temperature, keep it for some more time. That what you call as a solution treatment. After that, quench fast. Then after some time, rise it to some temperature, well below the solution treatment temperature. Then maintain that temperature so that precipitation is occurring. This type of treatment, what is known as a precipitation heat treatment. It is mostly used to increase the yield strength of malleable materials. Thank you very much for watching this video.